Albertosaurus, the top predator of late Cretaceous Canada, is one of the most well-known theropods among the vast majority of fragmentary ones. Albertosaurus got its name from the province of Canada in which it was discovered. The top predator of its region, the Alberta lizard, would have had no other predators big enough to compete for resources within the northern parts of North America. Albertosaurus shows a wonderful example in the line of Tyrannosaur evolution, showing a transition from a lithe and streamlined form into that of a more heavily built predator like Daspletosaurus and eventually Tyrannosaurus. The type specimen of Albertosaurus consists of a partial skull. This specimen came from the Horseshoe Canyon Formation near the Red Deer River in Alberta, Canada. Paleontologist Joseph Bird Tyrrell uncovered the type specimen. However, he could only partially secure the find due to a lack of specialized equipment and only acquired a part of the skull. In 1889, Tyrrell's colleague Thomas Chesmer Weston found another specimen, this time an incomplete skull smaller than the first and located nearby. These two specimens were placed under the species Laelaps encrasitus, named by Edward Drinker Cope in 1892. The name Laelaps has been previously attributed to a kind of mite, and thus made the name a nomen dubium. Othniel Charles Marsh, Cope's rival, renamed the genus Dryptosaurus in 1877. Edward Drinker Cope refused to acknowledge his rival's decision and continued to use Laelaps as a legitimate name. Many remains were uncovered after the fact, going unnamed, until Henry Fairfield Osborn, a well-known American paleontologist, coined the name Albertosaurus in 1905 when he wrote his description of the much larger Tyrannosaurus. Later on, in the year 1910, famed paleontologist Barnum Brown uncovered the remains of a mass of Albertosaurus near the Red Deer River. Due to the large amount of individuals, Brown and his expedition were unable to collect all of the specimens. They took the important identifying fossils, which told them that at the site lay at least 9 individuals. All in all, 1,128 Albertosaurus fossils had been uncovered from the bone bed, the largest concentration of theropod fossils ever found in Cretaceous sediments, which is why so much is known about this animal's biology. Due to the large amounts of sizes and ages of the individuals discovered near the Red Deer River, the ontogenetic cycles of growth for Albertosaurus is relatively well known. Remains approximately 2 years of age, measuring 6 feet long and weighing no less than 110 pounds, showcased the youngest individual. The eldest specimen found consisted of a length of 33 feet and may have been 28 years of age at the time of death. The growth and death rates of the boneyard in the Red Deer River compared with the other Albertosaurus finds suggest that the animal grew at an exceedingly fast rate along a 4-year period that ended at approximately age 16, which began the onset of sexual maturity. This growth is unlike most avians and is more akin to the growth rates of large mammals. These statistics also revealed a hypothesis concerning the mortality rate. The theory suggests that the hatchlings had a rather high mortality rate, explaining why fossils of young individuals have not been commonly discovered. Then, after 2 years of growth, the animals would have been much larger than many of the predators it shared its ecosystem with, and the death mortality decreased sharply. However, the mortality rate again increased, doubling at around the age of 12, and then doubling again at around the age of sexual maturity. The find of dozens of specimens in the bone bed of the Red Deer River might suggest that the animals hunted together in packs. This theory has been suggested for many theropods found together, but the opposing theory to this is that they may have been killed due to environmental reasons and then deposited together after death. Canadian paleontologist Philip J. Currie suggests that the legs of the younger Albertosaurus might have helped them draw the prey towards the adults that were slower and more powerful. Currie speculates that the young Albertosaurus, having different adaptations compared with the adults, may have had a different way of life, similar to the Komodo dragon of the present. Young live the lives of insectivores, while adults are the largest predators on their island, attacking and killing water buffalo. Due to the fact that behavior does not fossilize, Curie's theory is speculation that cannot be tested. However, what can be observed is what it lived with and what it hunted. All of the Albertosaurus material is known from Canada, most of which is from the Horseshoe Canyon Formation, housing fossils from the Maastrichtian age of the Cretaceous period. Other species found in and around this area and time include Didelphodon, Champsosaurus, Saurolophus, Hypacrosaurus, Albertonicus, Pachyrhinosaurus, Ornithomimus, Stegosaurus, and many more. Albertosaurus would have been the top predator of this ecosystem and might have preyed on most of these animals. However, Pachyrhinosaurus grew to be one of the largest ceratopsian dinosaurs in existence, and would have given even the adult Albertosaurus trouble. Potential evidence for pack behavior. Albertosaurus may have lived with its cousin, Gorgosaurus Adaspledosaurus. Albertosaurus is placed inside the subfamily Albertosaurini, the only other member being Gorgosaurus. This subfamily showcases animals of a slim build and capable of quick movements, unlike their descendants, which include Daspledosaurus, Teratophonius, Bistahi eversor, Tyrannosaurus, and Turbosaurus. This predator may have been at the top of the food chain, but environmental disasters have no bias and kill without mercy. Whether Albertosaurus fell prey to the elements or each other, they all ended up in the same place, to be uncovered by our species many millions of years later. We learn from these fossils of how the Earth was at the previous time to help us understand the Earth as it is today.